Hello, my name is Dr. Kaplan, and I'm a professor at the University of Texas at Austin in the astronomy department. I'm currently up at McDonald Observatory pretending to observe planetary nebula. The date is January 26, 2014. Now, while my colleagues back in Austin think I'm trying to observe planetary nebula, I've taken the opportunity to observe something far more sinister. Now, as some of you in the UFO community might actually be fully aware of, despite the government cover-up, there is a threat to our planet, the planet Earth. There's a planet at the edge of our solar system some call Nibiru, or Planet X, and it is currently on an orbit that is going to cause it to swing by the Earth in August, and who knows? Hopefully it won't collide with us, but even if it just gets close, the tides will just cause earthquakes, tsunamis, will reconstruct the surface of the Earth into something we don't even know. So I've taken the opportunity, since I'm at the observatory and there's no one here watching me at the moment, to track the planet Nibiru, and I will show you how it's done. Now, if any of my colleagues, if NASA finds out, if the government finds out I'm doing this, I'm through. So hopefully I can get this up on YouTube before they find me. So right now we are in the control room of the 2.7 meter telescope at McDonald Observatory. Now, the first thing I had to do before I was able to come up here and start tracking the planet Nibiru was find its coordinates. Now, its right ascension and declination are a closely guarded secret. So, using my credentials, I was able to get a tour of the Johnson Space Center down in Houston. And I was given access to their computers. Now, using hacking methods that I am not at liberty to describe, I was able to hack into their computers and steal the right ascension and declination of the planet Nibiru. So I knew exactly where to point the telescope. Now, I'm going to give you those coordinates so you yourself can go find Nibiru. Now, keep in mind, Nibiru is fast approaching Earth, so its position is going to change rapidly. So you'll have to, I don't know its exact orbital parameters, so that's what I'm trying to find out. Now, its coordinates are currently, as of this time, right ascension, 04 hours, 8 minutes, and 8 seconds. And the declination 60 degrees, 56 arc minutes, and 43 arc seconds. Now, if I get the correct orbital solution, I'll be able to plot exactly where it's going to be over the coming months so that we can figure out if it's indeed a threat to the Earth or not. So, this is a spectrum of Nibiru. Now, it uses an instrument called the Mitchell spectrograph, which actually gets spatially resolved spectroscopy. The planet Nibiru is actually so close to Earth at the moment that we actually can see a disk. So the optical fibers are placed in the focal plane, and I'm actually getting information about the atmosphere or surface of the planet Nibiru. Now, I haven't analyzed this data, but this might tell us something about what type of object it really is. Now, as you can see, it also has several spectral lines, and those spectral lines are Doppler shifted towards us, sort of like how, you know, a police officer can use radar to figure out if you're speeding or not. And as of tonight, it is moving towards us, I calculate, at about 200 kilometers per second. So that means it will, if it's on a collision course for the Earth, hit us in about August 2014. Okay, now I'm going to go out in the telescope dome and show you the instrument I'm using. Now, it's almost completely dark out here, so I brought a flashlight. Okay, so we're now out in the telescope dome, and this here is a telescope I'm using to track Nibiru. This is the 2.7 meter telescope at McDonald Observatory. The instrument I'm using to take spectra is called the Mitchell spectrograph. It's also known as Virus P, because it's a prototype for the virus spectrographs going on the HET telescope. Now, it's kind of hard to see, but there it is. There's Virus P. It's that black box surrounded by that blue frame there. So right now I'm currently tracking Nibiru, and I'm gonna try to track it for as long as it's high enough in the sky for the telescope to see. So this is the telescope console that I use to control the position of the telescope manually. Now, when I first point the telescope, I use this hand paddle here and actually this little joystick to move it. So you can move this giant, 50-ton thing with just a little joystick. Now, this computer here is the guide camera. This is what actually causes the telescope to track. Now here you're actually seeing the planet Nibiru. This is probably some of the best footage you will probably ever see on the internet of the planet Nibiru. Now as it gets closer to the Earth, it will actually appear to grow in size. So if I come back, say, a month later, it might be, right now it looks like that, but it might be that big. So we're actually pretty zoomed in here. This is a field of view that's about, 120 by 120 arc seconds. Now, to calculate an orbital solution for Nibiru, I have to observe it over several nights. My observing run, which I propose to observe planetary nebula, is for 4 nights. So hopefully I'll get enough information about its changes in position over the 4 nights I have to be able to calculate a decent orbital solution. And also from the spectra I'm getting, I'll be able to tell its motion towards or away from us. So I can actually get 3-dimensional information. Now this is the all-sky camera here. This is showing us sort of a fisheye view of the sky. Currently there's no clouds, which is good because in order to get a good orbital solution for Nibiru, I need to observe it continuously over 4 nights. And if I have poor weather, then it becomes harder to figure out what's going to happen in August when Nibiru comes very close to the Earth. Yes? Yes? No, I'm not. I am pointed at planetary nebula. I'm observing NGC 1501 right now. What do you mean the telescope's now pointed at NGC 1501? Of course it is. There's something wrong with your software. No. No. It's right here. You want me to... So that was just the director of the observatory calling me, making sure that, I don't know, usually the director's not here or asleep by now. It's about, right now it's about 10 o'clock, and it's unusual for the director of the observatory to call you. Now, I think he might be in on what I'm trying to do, so I'm probably going to have to point the telescope somewhere else until he goes to sleep. See, all the things I'm doing get put on the observatory. Anyone can just look up exactly where I'm pointing the telescope. And especially the director of the observatory who has the password to all the computers. So hopefully everything will be fine. Okay. Clearly the director knows that I'm not observing the targets I plan to observe. In fact, usually when we switch targets here at McDonald Observatory, we have to update our observing plan so that they know, that the science we're doing is worth, the cost of running the telescope. They keep logs on everything. So here's an email I just got from the director asking me to update my targets as soon as possible. Dear Dr. Kaplan, blah, blah, blah. It appears that you're not observing the planetary nebula and you are deviating from your original observing plan. Please update with us with your targets as soon as possible. Sincerely, the director. So, I'm just going to tell them that I found new planetary, better targets to observe. So hopefully they'll believe that long enough that I can get this video out. Now hopefully NASA hasn't figured out what I'm trying to do. Crap, I think someone's coming. I'm gonna go see who it is.